In my last lecture, I introduced the recommender systems and we learned the user-based collaborative filtering, which focuses on the similarity between the user and user. Today, we will learn item-based collaborative filtering, which is another version of simple collaborative filtering methods. Before talking about today's main content, let's review programming assignment for the last lecture. You can see my sample answers for programming assignment through this URL. Click this URL, then click this link at this section, sample answer to assignment on this web page. Then your browser opens programming materials on the Google Colaboratory website. I have uploaded my sample answers for programming assignment about the user-based collaborative filtering. If you're interested in, check and enjoy them. Okay? Oh, let's go to today's main contents. Today we will learn item-based collaborative filtering. Before learning item-based collaborative filtering, let's think about the problems on user-based collaborative filtering. We learned user-based collaborative filtering in the last lecture. The method has problems for practical use. As we already learned, user-based collaborative filtering tries to predict a target user's rating score for an item by focusing on rating tendencies of similar users. For example, assume that we want to predict the Alice rating score for item 5 now, here. Then if we use the user-based collaborative filtering, we focused on the rating scores of user 1 and user 2. This is because these two users are similar to Alice in terms of rating tendency. Once we found the similar users, we can predict Alice's rating scores for item 5 by using this formula and similar users' rating scores. In order to calculate the similarity between user and user, we can use the Pearson's correlation coefficient. This Pearson correlation is a very popular metric to compute the correlation between two variables in statistics area. User-based collaborative filtering is very intuitive. It's very easy to understand, but if users haven't rated the same item yet, we cannot compute the user similarity. Let's see this example. Here we have rating a table. On this table, we can see 5 users rating information, including Bob. Now we want to predict Bob's rating score for item 1. In this example, you know Bob hasn't rated item 1, 2, 3, 4, and 4 yet. Unfortunately, there is no intersection between Bob and other users on rating information. Then we cannot compute the user similarity between Bob and other users. In order to compute the user similarity, two users have to rate the same items. However, in general, it is rare that two users rate a lot of the same items. Of course, the users rate a little the same items, but as an example between the Bob and user 4 on this table, if users rate only a few the same items, user similarity drastically changes if a few ratings are added. Here are other problems on the user-based collaborative filtering. In general, the number of users are much bigger than the number of items, and so we need big computational costs to find the similar users. Furthermore, user preferences are unstable. The preference often changes depending on the time. On the other hand, item features do not often change. Well, we have to handle with these problems for recommending the items to users. So item-based collaborative filtering tries to deal with these problems. So let's learn this method. Item-based collaborative filtering is quite easy and very similar to user-based collaborative filtering method. The idea of item-based collaborative filtering is to focus on the rating tendency for similar items for unknown rating score prediction. For example, assume that now we want to predict the Alice rating score for item 5. From observation, we find that item 5 is very similar to item 1 and item 4 in terms of rating tendency. And then we predict Alice rating score for item 5 by using information on item 1 and item 4. This is the idea about the item-based collaborative filtering. What are the advantages of item-based collaborative filtering? The one is computational cost. As I already explained, in general, the number of items is much less than the number of users, and so we can make the computational cost of item-based collaborative filtering smaller than the user-based collaborative filtering. Another advantage is stability of the similarity computation. Item feature vectors don't often change comparing with user preference vector. Also, comparing with user preference on a rating matrix, item feature vectors have less non-value dimensions. And so we can compute the similarity between items using enough information. Let's see the detail of item-based CF. At first, let's see how to compute the similarity between item and items. User-based collaborative filtering uses the Pearson correlation coefficient for similarity computation. On the other hand, the item-based CF uses the cosine similarity for similarity computation. Cosine similarity is the one of the similarity metrics. It focuses on the angle between the two vectors. The similarity ranges between the -1 and 1. It is known that the cosine similarity shows the best performance for item similarity calculation. This is a formula for the cosine similarity computation. Using this formula, we can measure how large is the angle between the two vectors. If the angle is small, that means the two vectors are very similar. This is an example of cosine similarity computation. On this table, the cosine similarity between item 1 and item 5 is 0.99, like this, if we ignore the Alice rating dimensions. For practical use, we have to modify the cosine similarity computation. The basic cosine similarity has a problem. Here is one example where we can see the problem. This figure shows the ratings of the Alice and user 1 for item 1, 2, 3, and 4. As you can see, the rating tendency of Alice and user 1 are very similar. However, Alice rates easily and user 1 rates strictly. Unfortunately, the basic cosine similarity doesn't take this difference in the average rating behavior of the users into account. How can we deal with this problem? The solution is very simple. If we consider the difference between the from the average, the ratings for each item don't vary between Alice and user 1. So we adjust the cosine similarity scores for improvement. We subtract the average of rating scores from each rating, like this. And then we calculate the cosine similarity using the adjusted rating matrix. Let's see an example on this table. This table shows the rating score of each user for 5 items. We can obtain the average rating score of each user using rating scores like this. Then we subtract the average rating scores from each rating scores like this. Then we obtain the adjusted rating scores like this. Now finally, we use these adjusted rating scores to compute the similarity between to compute the cosine similarity between the item and item. Once we can compute the item similarity, we can predict the rating scores of users for a target item by using this formula and the similar item set. This formula seems complicated. This formula just compute the weighted average to predict a rating score for a target item. As a user-based collaborative filtering, we need to set a threshold to find similar items when using item-based collaborative filtering. We have two approaches to choose the similar items. The first one is to set a threshold for item similarity. If an item has higher similarity than a threshold, we regard the item as a similar item. The other method is to focus on the top k similar items. If an item ranks at the top k similarity, we regard it as a similar item. Typically, a threshold k is often set to between the 50 and 200. Okay, that's all about the item-based collaborative filtering. Here is a summary about today's talk. Today we learned about the item-based collaborative filtering. Next time we will learn more modern collaborative filtering methods. Okay, to learn item-based collaborative filtering practically, I have prepared the programming work materials. I've uploaded several materials on this URL. Please visit this URL. Then click this link to learn the item-based collaborative filtering. Then your browsers open programming materials on the Google Collaborative website. As the last programming work, all programming codes are ready to learn. All you have to do is learn the Reddit codes to see how collaborative filtering methods work. At the bottom of this material, I have prepared several programming assignments. These are just for the practice. You don't need to submit your answers to me. Just enjoy them if you are interested. Okay, that's all about today's lectures. See you next time. Bye bye.